Okay, hi everybody. Thanks, Jules. We're going to be talking about how you can use how you can use Spark with a operational database to make it work better. What we're going to talk about first is why you would want to do this. So start from a very high level. What's the big idea? How do these systems complement each other? And from there, drill down into a little bit. We have to give a little bit of background about why the connector between, in this case, Couchbase, is designed the way that it is. So you need a little bit of Couchbase background. And then we'll hit a couple of specific points about why that integration works the way it does and what we do to make it work well, by which I mean usually fast. And then Matt will give a demo. OK, so at a very high level, Spark does very different things than you get with an operational data store. So it does analytics on the big scale, and I know you're here at the Spark Summit at the second day. I'm sure you've heard all this stuff. But you're going to get a lot of machine learning or sort of advanced analytics things out of the Spark cluster. So if you think about a catalog application, the recommendations and things may be built in a Spark cluster and be served to a lot of users out of the NoSQL data store. You might be doing sort of advanced next-generation data warehousing where you're doing a lot of interoperability with Hadoop and other systems and feeding that into something like a NoSQL system to serve it out at scale. Predictive analytics to decide what song somebody might like to listen to and serving that out of a NoSQL system. And so forth. So at a high level, the operational stores and the analytics stores don't really try and solve the same problems. So the Spark is going to give you, as I said, the analytics and machine learning, whereas something like a Couchbase or another NoSQL store is going to support the direct access from the web and mobile users. That's going to give you the sort of online processing where you have lots of random reads and writes and things that you don't really, Spark is not optimized to solve that kind of a problem. Spark will give you the ad hoc queries, which Couchbase can also do, but it can do the big batches, it can do stream processing and so forth. And it is lower latency in general terms than Hadoop. I know people argue about that, but it's really optimized for high throughput. So that's what Spark does really great. High throughput, lots of data, whereas a Couchbase is going to be optimized more for a consistent low latency type of response, so sub-millisecond response at very large scale for key value gets and sets, and that's why people use these systems together. And you're going to see a very predictable performance curve with a NoSQL store, as opposed to like on a Spark, because it's job based and because there may be other things going on in the cluster, you may have certain things that run slower or faster at different times, and you don't want that in the system where somebody's there pressing the button, trying to do their shopping or whatever. Another kind of obvious difference here is that in the operational world, you may be supporting hundreds of millions of customers on this Couchbase cluster. On the Spark side, you may be serving, you may be crunching data for that many users, but you don't have that many end users directly connecting to it. It's your data science team, it's your analytics team, and then you're piping it out somewhere else. So we really talk about two main use cases for NoSQL and Spark together. In one example, you have all this machine learning case where you build big models on the Spark side. You may be connecting to data warehouses, Hadoop clusters. You're probably crunching lots of historical data. And then you're building these models that you're serving out to the NoSQL side. And so you may have something that looks a little bit more like this if you drill down a level. You're building models on the Spark side. You're serving those as predictions to the NoSQL. You're sending them as predictions to the NoSQL layer, and you're serving them out to your end users. Maybe you have a thin layer like Node or something like that. But the actual NoSQL store is managing the persistence. So if you think about something like a shopping application, I put something in my cart that may be observed, or I go browsing something that may be an observation that gets fed into a model, maybe updates the model, and then comes back as predictions. We'll talk a little bit more about cases like this. This is really the thing that Matt's going to demo, is more like this case. This is the second use case, and this is really enabled by the fact that Spark connects to absolutely everything these days. It connects to almost every database you can think of, everything in the Hadoop space, all the file formats, the Parquets, the Avros, anything that you see on Amazon, you can grab it on Spark, you can query it, and so that makes it very flexible. I modified this nice Databricks slide by putting the Couchbase logo on the corner, but all the data access possibilities that Matt's going to talk about today through Couchbase, we've exposed those, and similarly, other people in the space have done the same. So that lets you kind of use those to great advantage, because you can kind of use these various data access methods in all these products. And so what that means is that Spark is kind of a great data integration tool, where as a guy, I can just fire up a script on my laptop. I can sort of query something from these various systems, and by writing some simple scripts, I basically have something that's like a data federation case, or some sort of better data integration tool that's very flexible and that lets me do what I need to do. So at this point, Matt, I'm going to hand it over to you to kind of go through the architectural background for Couchbase.
Great, thank you. Good afternoon. So I'm a software developer, right? And like many of you, when I'm wanting to work with the system, frequently one of the good things about a well-designed system is if I can be abstracted away from a lot of the logic that might be behind what's actually getting my work done. That's actually one of the things that I really like about Spark, is that you can focus specifically on how you're processing the data. You're not having to spend a lot of time thinking about how you're going to distribute that to the cluster, the DAG, and the rest of Spark will work out. Not always all of the details, but a lot of those details for you, and you can focus on the business logic that you're trying to achieve. In the case of Couchbase, we actually designed the system from the ground up to be roughly the same. So when you're, the programming model that Couchbase exposes to you as a developer is a programming model of a cluster, of services on a cluster, of different data access patterns on a cluster, and you don't necessarily need to know what's happening underneath as data is sharded across the cluster. That said, it's useful to you to understand how we've designed the system to make sure that you get the maximum benefit out of it. So if you were to look at Couchbase, you actually have kind of 5 different data access patterns, and I could go into a lot more detail, but just at a high level, there's a key value data access pattern, right? You're dealing with JSON objects typically. You can store other objects, but typically JSON objects. And so that's really just a JSON object that you're trying to store into the system and retrieve it later. Query, give a set of query parameters, a set of query criteria. Go find me the things that match this particular range and maybe have this particular size. Then we have a couple that are unique. MapReduce views. This actually comes from our CouchDB heritage, so to speak. Just a brief aside, Couchbase and CouchDB are actually different. Some of the committers behind Apache CouchDBs were some of the creators of Couchbase originally, and so we drew a lot of what we'd learned in that project into Couchbase itself. And one of those is the MapReduce views. There's also a data streaming way of accessing data to Couchbase. So especially in modern systems, you need an efficient way to stream data between systems. So we actually put together a way of streaming data out of Couchbase that is very efficient and very quick. And finally, there's full text search. That one's actually brand new. So it's coming up in our next version. And the cool thing is that 4 out of 5 of those actually have a way to get to through the Couchbase Spark connector. So I want to give a little bit of an overview of how the system is designed around those features, and then I'll show you how those connect into Spark. So briefly, when you're dealing with data in Couchbase, we hash partition the data itself across the cluster, but we do it in a relatively unique way. We're not the only people that have ever done this, but we're kind of we're unique in the NoSQL space, and it gives us a few particular advantages. So in Couchbase terminology, there's something called a bucket. A bucket is really analogous to a database. It's a space, a namespace for unique keys. Within that bucket, we slice that up into 1024 vbuckets, and so that's 1024 slices of data. And then what we do is we map those 1024 vbuckets to physical nodes. Now, on the application side, we take something called the cluster map and put that into the application. And what that actually gives us is a couple of things. One is that any application at any point in time knows exactly which node is responsible for a given piece of data. So it doesn't even have to go through a metadata lookup to know where to go for a piece of data. The other thing that's important from that perspective is we're able to easily iterate over all of the data within that V bucket, and we use that to move that logically mapped data, that data that's logically mapped to that V bucket to a physical location. And that's part of why it's very easy to, say, work with Couchbase and changing the cluster topology. But that also has an impact in how we stream data. So that's just one thing to be aware of, is that the data is hash partition, makes it really easy to spread the load out among the nodes, but then there's also an easy way for us to identify a particular set of data and stream a particular set of data. Then there's a nickel query. Nickel, N1QL, and it's pronounced nickel. It really is SQL. So it is the SQL language with some extensions that the N1 actually comes from something called non-first normal form, with some extensions that make it very appropriate for working with hierarchical data. So within a Couchbase cluster, nickel has stateless execution. However, you need to, when you're trying to, say, query a system, one of the important things that you need to have to make it perform is what? There you go, indexes, right? We got to have indexes, and when you want that to perform really well, you really want to have probably the most selective index that you can to be able to reduce the amount of data that you're going to consider in execution of that query. And Couchbase has that as well. So in addition to the hash partition data, we have range partition indexes. And the range partition indexes are through something that we call global secondary indexes. Both of these can run on any part of the cluster and are easily accessible to applications, including those that you're using through the Spark connector. Then we have something called MapReduce views. I won't spend a lot of time on that, but there are some unique properties to that. It is incrementally processed, and the MapReduce there is actually authored in JavaScript, which makes it, it's not like a Hadoop MapReduce, for example. So very easy and straightforward to process JavaScript. And then finally, there's data streaming with what we call the Database Change Protocol, or DCP. And that allows for streaming all of the data out of a Couchbase cluster, and then stopping or continuously streaming, or just stream whatever you want at the time of connection. And that allows you to plug that into a few different use cases. So now that you have just a couple of those fundamentals out of the way, let's talk a little bit about Couchbase from Spark. So again, I mentioned kind of those 4 different ways that you can access data from a Couchbase cluster using Spark. How would we hook those up to Spark directly? Well, in the key value case, pretty straightforward. Produce and store RDDs as needed. Query, well, Spark has Spark SQL, and so we can take the Spark SQL interface and implement that connected down to Couchbase, and there's some unique ways that we're able to do that in a really efficient way. Then there's querying Couchbase for RDDs through the MapReduce views, and finally, there's exposing that DCP streaming interface. So I want to walk you through just a few integration points of interest on this. So the first one is data sharding and data locality. One of the nice things is that when if you are to co-locate a Spark node and a Couchbase node, Spark will actually allow us to push location hints into where to process that data. And the cool thing about that is that, say, for example, you have a large amount of data, you have a stream of items that you're going to process or documents you're going to process. Sometimes they use the terms interchangeably. If it's really intense, we can actually push some location hints into Spark, and then we'll co-locate that processing. So we're grabbing it from the local node, processing there locally, and putting it back on the local node. So you don't actually have to transfer things across the cluster. And then the other thing worth mentioning is that we actually do pipeline internal to the Spark, really to the I/O core that the Spark connector uses. If you're grabbing a large number of items, we'll pipeline that I/O underneath. So it isn't just individual data operations, but it'll start to pipeline that I/O. So we can get very high performance off of the cluster. With query, the really important thing or point of interest there is predicate pushdown and global indexing. So talking just a little bit about the interface that Spark gives us, Within Spark, there are a few different interfaces we could implement, right? There's table scan. That one's pretty straightforward. Give me everything, and then Spark will apply its filters and predicates. There's prune scan, which is really a question of pruning the data, but not necessarily filtering, and so then Spark would be responsible for filtering. And then there's prune filtered scan, which is scan whatever the appropriate index is in the system underneath. It, of course, depends on how that system's implemented, and return only the relevant data to that query at hand. The cool thing is that with Couchbase, we've been able to implement a prune filtered scan. So all of the predicates that you provide into your Spark program using regular Spark SQL terminology just gets turned into a predicate that's pushed down to Couchbase and automatically will do the pruning and filtering at that data level. I'll talk a little bit more about that in a moment, but really what that gives you is that really high efficiency of data transfer and what you're accessing. So with respect to how things are organized, just super quickly, thinking of that Spark application, maybe you've got this orange, that could be a Spark cluster that's accessing it. And you're going to have those regular data updates, and those are moving across the hash partition data nodes. But when you happen to execute a query, in that case, we're going to, through the query optimizer, pick the most selective index, use that most selective index to determine what data items to stream out, apply filters, and then we return that up to Spark. And we've implemented just a very large number of predicate pushdowns. That's just a quick copy straight out of the code. However, a couple quick notes. Spark assumes that if you're happen to try to implement a connector, Spark assumes that it's getting all the data, so it actually reapplies those predicates. It won't hurt you in that case. It's just a little bit of extra processing. And in the future, we're actually looking at some additional optimizations of how we can push some, get some additional work pushed down. One other point of interest is that data streaming. This is going to fit very clearly into something I'm hoping to show here in a moment. So just to remind you, DCP, the Database Change Protocol, we've defined a protocol that allows us to stream data across different clusters or different nodes. And here in the modern world, right, a lot of architectural systems depend upon streaming data from one set of systems to another. There are a few different cases of that. One would be the Lambda architecture that Nathan at Twitter had originally kind of popularized. The other one that actually comes up more in the relational database world, but it's a variation on it, is something called CQRS, Command Query Responsibility Segregation, really where you're processing data after it comes into the system to create indexes. And a lot of those rely on being able to stream data. So with DCP, really what we have is the ability to stream data out of the system out to Spark or whatever other system. We actually use DCP even for building our own indexes, then do additional processing at that level. So I've gone through that really quickly. I want to jump into a demo, if that's OK by you guys. So what I think I'm going to show, let me give you just a quick overview. So I'm going to jump straight to a transformation demo. Before I run through the demo itself, if you're a developer here, right, one of the things that's great about a NoSQL system versus, say, a relational database system traditionally is on a relational database system, say that product manager comes along and says, hey, I need a new feature, right? And then you as a developer say, OK, I got to get a column to stick this data into. Now I got to go to the DBA. It's going to take a while. Maybe it'll be 3 months. 6 months later, you've got the feature for your product manager. In the case of NoSQL systems, you don't actually have to, you as a developer can just simply add that field to that item. However, there are still some use cases where maybe you want to do a big transformation on a system. So what I have here is I have a Couchbase cluster. This one happens to be just on my local laptop. Couchbase runs on Mac OS and Windows intentionally. We do a lot of work there to just make it easy for development. And if I happen to look at a bucket, I have a bucket here called transformative. Just for this demonstration, all I've done, oops, let me get to the right place. I've stuck a few thousand items in there, just generated some fake data. And if I look at a document, we'll look at Aaliyah Allison, who came up at the top. You'll see that this is a basic user profile. Now assume that I need to pull a set of data in from an external system and then I want to get a stream of data from Couchbase, and I want to map some things together, and then do a transformation and restore that data back to Couchbase. So what I'm going to do is, in this case, the partner system, assume I get a set of data from a partner, and I need to stick an entitlement token into each one of those documents. So for Aaliyah needs to get an entitlement token if she exists in the other database. What I have here in this particular case is I'm just using MySQL as the other data source. Frequently when I do this, I like to use a Hadoop cluster. However, trying to run a Hadoop cluster, a Spark cluster, and a Couchbase node all on my laptop is sometimes a little bit slower of a demo, so I'm just going to use MySQL in this case. Hope you don't mind. And really all that has is, if I describe the table, you see that I have a table that has given name, surname, email, and entitlement token. So let me pop over to the demo itself. So down here, we're creating a Couchbase stream. This is the Spark dstream interface. It has a name. All we're doing is we're applying in Spark, we're applying a filter on the dstream. There are a few different kind of checkpointing type things to tell you what's happening with the cluster upstream. And really all we care about is the mutations in this case. So we're just filtering out the mutations. And then based on the mutation, what we're doing is we're going to grab the content out of that, and we're going to see if there's an entitlement token. Now, if there's an entitlement token on the document already, there's no reason to stick another one on. Obviously, that one's already been processed. And that's actually kind of important because we're going to run things potentially through the system. You know, as we're streaming data out of the system, we might get it again. So we only want to process the ones that we get out of the system. Then we're going to do this join on something called entitlement sans schema. So really what that comes back to is I was loading the entire MySQL data set. In this case, it's a small data set, and I can load it into memory. And I had to turn it into a set of RDDs because when you're working within a context, you have to stay within RDDs. And you can't necessarily work within data frames in this particular case. That was a limitation at the time that I'd written this. And then I have a simple function here that's just merge into doc. All merge into doc does is it takes the document that I have, the RDD that maps up to it, and then it puts the new entitlement token into it. And then finally, we're going to save that back to Couchbase, right? And so what we're expecting to happen when we run this is if I look at Aaliyah Alston, here. After I run that, I should see an entitlement token. So let's go ahead and give it a run. Let's see where we end up. Oop, that was the wrong program. Stop. OK, let's try to run the right one. I have two named transformations, so we'll run the transformation example. So what should happen here is, it'll go by pretty quickly, is if I go back over to the data bucket and I go to transformative, we should see, by the way, this is just the regular Couchbase console. So all of this runs, whether it's a cluster or a single system, you get this global view of what's happening in the cluster. So as you can see, a DCP connection started. I'll kind of zoom in there. A DCP connection was created when I started running that. And then what we should see is we should see a bunch of sets occurring. And sure enough, we have, we're doing only about 1,000 ops a second, which for Couchbase isn't a whole lot. But if I have a look here, you know, those are all set operations because we're retrieving the documents, doing the transformation, and then storing them back. And because it's doing about 1,000 a second, and I have only about 10,000 documents, we're now back down and we're done. Now, if I were to go back over to the transformation, you'll see this block input that's basically complaining, hey, you have only one Spark node, you really need to replicate that, but that's expected because it's a developer environment. But then eventually you'll see all the logging that as we're processing that D stream. The other thing that we should see is if I were to now go back into the bucket browser and look at the documents, I should see an entitlement token on any of the documents that were in that other database. And sure enough, Aaliyah Alston now has her entitlement token. So I got through that one pretty quickly, but that was a quick demonstration. With 1 minute, I'm going to try to do one more. I know Jules wants me to get to Q&A, but I want to show one other quick thing if you're interested. So I'm going to stop this. Oh, the other thing worth mentioning is the stream is continuing in this case because I said run until termination. So I'm going to stop that one. I put together one other quick one. One of the other things I find powerful in this case is you can actually use Spark itself to join two different data sets, right? And in the case of Couchbase, because we have that predicate pushdown and we're doing that very efficiently, we have the ability to maybe take something, say from Parquet, and do another join on that data set itself. So here what we have is that same Couchbase node has another data bucket. It's the travel sample data bucket. This is the one that we use for lots of demonstrations. In the travel sample, we have things like airports and landmarks and so forth. And what I've done earlier is I went and I took all the landmarks and I just wrote them out to a Parquet file because I wanted to show you this idea of doing a join. So now that I have that landmarks Parquet file, I can just read that in. Then I can do a query against Couchbase for all the airports, go find the ones that are SFO, and then do a join between those two data sets. And then I should see the top 20 landmarks that are near the SFO airport, right? So let's try to run this one. Oop. Parquet join, run. This is one that I usually, again, kind of run with HDFS. Running it just with a straight Parquet file makes it a little simpler. And sure enough, so what we see is a very quick, we did the query against Couchbase, which was processed very quickly because we pushed those predicates down to the system, did that B tree lookup, whether it's a small cluster or a large one, and then we pulled the top 20 landmarks back out. So with that, I think I want to turn it back over to Jules, and we're going to go to questions.
Thank you very much. I love the live demos. Any questions? We've got about 2.5 minutes. Go ahead.
Hi, thanks for the presentation. It was a bit unclear in your presentation. You mentioned you would support RDDs, but then you talked about sparse SQL, so you actually have data frames API as well?
We do have data frames, yes.
And how does it actually work with the columns then? Does it return you a data frame with maximum number of columns that you have in your document list? Or, I mean, you have, let's say, 1 million documents, and each of them have different number of columns. Will it just make a full entire set of the columns and then?
I'm not 100% certain. Okay. I wish most of the time it does turn out. You'll notice that when I did that query, it does turn out that even with a NoSQL system where you have complete, total, flexible schema, most of the time that's generated by application code, and most of the time you're focused on a certain set of items. So usually the schema is relatively uniform, but not necessarily. I can get a specific answer.
You can determine the you can say, hey, use this schema.
That's true.
And so in a lot of cases, that's what people do. We actually had some material on that, but we cut it for time purposes. But Couchbase itself has an infer command that you can run that will give you some information about what your data looks like.
Okay.
And people often will then use that to determine the schema to pass when you use data frame.
All right. Thank you.
Anybody else? We've got
There's a question.
Another minute.
So in use as an enrichment database with a pipeline, often you find the need to have, say, generations or releases. If I had a model that I'm loading in there, what's the paradigm in Couchbase for doing that? Is it namespaces? Is it object versions? Is it key spaces? What's just in general?
So there are, I guess I'd say there are kind of two big ones. Typically what happens is it's the outside application that determines how that sort of schema migration occurs. And usually what will happen is people will just do the enrichment at the time of reading and writing the particular objects. So the demonstration I had here was kind of trying to show a different sort of approach. Not always. So I would say most of the time we kind of approach it based on the needs. We do have some very large deployments. Viber is one where they just have hundreds of millions of people, literally, in Couchbase. And so the idea of trying to just come up with a generation for that doesn't work particularly well. So they have very defensive coding, things like that, for being able to deal with it.
Okay, thanks a lot. That's all the time we have. Give a big hand to Will and Matt. Thank you.